All right, so this presentation is going to be on soil structure and sizing up soils. Okay, so I know a couple weeks ago we already went really hard into this conversation, but what is soil all about? We have soil that has different textures, and each type of soil you touch is going to feel different because they have different textures. And you guys already know this, so it's going to be a review, but the soil textures is the percentage of what? We have sand, silt, and clay particles, and that will give you what soil texture that you have. Soils have many different types of structure. Beds are the clumps of soil that form building blocks of the structure. In between beds, there are pores, which are the spaces between the beds. Pores are very important for moving water through the soil and having space for roots to grow through the soil. So now we're going to look at the different kinds of soil structure that you guys need to be able to identify. So the first soil structure on the list is granular soil structure. It almost looks like Parmesan cheese. It has those different soil aggregates that are very crummy and cheese-like. Granular soil structure is the best for farmland. This type of soil structure has a lot of pores, and it is found in very great in gardening. Why do you think that this kind of soil has a lot of pores? Because look at the photo in front of us. Look at all the pores between our different particles and our different aggregates that we have. This is why it has so much airflow and pores that go through because of this soil structure. Due to this, this is the most desirable soil to have on the soil surface. And a lot of times this also has the appearance of almost like a cookie crumb, and you can think of a cookie crumb or that Parmesan cheese again. And this is the best kind of soil structure that we want to have because it has the most amount of aeration and water retention through this because of the pore spaces. Now we have blocky soil structure. Now, these shapes are cube-like, and they either have very sharp or smooth edges. They're commonly found in the subsoil. And you can remember this because it looks a lot like Italian sausage. And here in that cartoon illustration, we don't have a lot of air spaces here compared to the granular. We do have some, but it's not as much because now we have a lot more. That soil aggregate is a lot bigger than the granular. The granular was very small, and that's why we had so many pores. Here, the aggregates are a lot bigger and then stacked on top of each other. Now we have columnar or prismatic structure, and this looks a lot like breadsticks. Okay, these beds are very tall and vertical shaped, and they have less pores than that blocky structure. And of course, they have less pores than the granular. And why did they have less pores? Is because how long it is, how those vertical beds are, and it's very columnar. We don't have those in blocks. We had different blocks that had a shorter length, and here we have a lot longer length, so that decreases the amount of pore space we have. And with a decrease in the amount of pore space we have, there's a decrease in the aeration and the water that's going through here as well. Next, we have platy structure, and this looks a lot like a stack of pepperoni. Ew. I'm vegetarian, so that's disgusting, but it does look like a stack of pepperoni. These are flat horizontal plates, and the water can move slower through these plates in comparison to the blocks, especially if there were a lot of clay. So here, the length is very short. The width is a lot longer. So now we have even more of a decrease in those pores, so even more of a decrease in water penetration. So that drainage is going to be a lot lower as well. And now we have massive structure, and this looks like uncooked pizza dough. And here we don't really have a lot going on. We really have no structure whatsoever. We don't have those breakups that we had in the rest of the different types of soil structure. It's just kind of a one piece, which if it's one piece, where are the pores at? And that kind of answers your question for the drainage as well. The drainage, it's really going to be very low, slow draining because there are no pores here. There is no kind of structure. So that is called massive. This kind of soil is not very useful for farmland whatsoever. And this can occur, this massive structure occurs if a clay soil is repeatedly squished and cramped together due to compaction until there are very little or no pores. The water cannot move through this layer because there are zero pores, and it usually means soil is in really bad shape. This can sometimes be found in construction sites because of the severe compaction. Now we have the single grain structure, and it's like a pile of salt. This soil has no beds and it looks like a sandbox or piles of salt. All particles are they usually stay separated, and this can be found at a local beach or sand dunes. So there's not a lot of aggregates here. The beds are non-existent. So here we definitely have a lot of pore space, but my question is, how is it going to retain a lot of water? And that's going to be lacking here. So this is pretty much saying, how much humans have impact on the soils and how much we damage the soil, especially the soil structure. Yes, it is very difficult to change a soil texture, but if you think that's difficult, it's way more difficult to change a soil structure after it's been destroyed by compaction. And we're going to have a whole presentation on compaction because it is very serious and everyone needs to know about it. But yes, so soil structure, once it is destroyed, you cannot bring it back to its original soil structure. It is very difficult. I will not say you cannot and it's impossible, but it is very difficult. I love this. Good structure equals healthy soils. Yes, that is perfect. And that is definitely a great quote to live by. And then another one is keep it covered. What do you think is meant by keep it covered? A big portion of keep it covered is ground covers and cover crops. The benefits that is provided here is erosion control. There are a lot more roots to hold the soil down. So now rain will not strike the surface of the soil and carrying it with its loose soil particles all over the place. It also gives extra plant roots. This not only do they provide roots to hold soil in place when they die, but plant roots contribute to the creation of organic matter. And this organic matter has enzymes that function as a glue to hold soil structure together. I mean, we saw all of the different PEDs. PEDs are created by these glues that keep all of those together. And adding organic matter, that's going to be our number one key to keeping that structure the way we want it. And if we have good structure, that means we have healthy soil. So I'm going to ask you a question. Why would you not keep them covered? Why do people not keep them covered? Well, there's two parts to that. In some parts of the country, it causes the soil to be too wet in the spring, especially under clay soils. And two, in some parts of the country, it's too cold. And soils take a long time to warm up to get a decent crop in. So we have those two things that we have to kind of play to. But the main point that we want to get across is we want that organic matter in there to provide, us with some good structure, and that good structure leads to healthy soils. Yeah, because I wonder what happened here. But the main point here is texture and structure work together to form a behavior. We look at soil and we can decide where the best places are to build houses. And avoid building houses or roads in areas that are likely to slide, like we have in the unfortunate picture that we see here.